Yeah, good evening. See, yesterday given this one. It is one show method, one print method, class B, extend CA, B class, void display, C. In this program, how many classes are there? How many classes? Two classes. What are those? A class and B class. Two classes are there. Okay. Between A class and B class, any relationship is there? Yes. Which relationship? Is a relationship. Is a relationship refers inheritance or composition? Inheritance, because extends keyword. Inheritance. Say creating a new class from an existing class is called inheritance. Okay. This is inheritance relationship. How many methods defined in A class? How many? Two methods. What are those? Show and print. How many methods defined in B class? Two methods. What are those? Show and display. Print method belongs to which class? A class. Display method belongs to which class? B class. Show method belongs to which class? A class or B class? A class. Not both the classes also. Okay. A class show method only overridden in B class. A class show method only overridden in B class. Okay. Yesterday one example I given. It is better to understand. So from relatives family, one person came and staying in your home, but that person not belongs to your family, like that. Okay. So A class show method overridden in B class. These examples only understanding purpose. These example don't give an interview. Okay. These example only for understanding. Now here A class show method overridden in B class. That means show method belongs to A class only. Show method belongs to A class only. A class show method only overridden to B class in B class. So show method having two definitions. Show method having two definitions. One definition in A class, one definition in B class. Okay. One person having two addresses. That type. One person having two addresses. One method having two definitions. This is one definition. This is one definition. That type. Okay. Now here in inheritance, you have seen four combinations possible creating objects. Four combinations. For example, according to this, suppose I'll create. It's a class. It's a B class. Inheritance relationship. It's a class. It's a B class. A, B. Now, see, A class, B class. It is super class. It is subclass. It is superclass. Here show method, here print method. It is subclass. Here show method, display method. Like this we have. Okay. Now object creation. Now first one, AOB1 equal to new A. If I write AOB1 equal to new A. A is here in this line, A class object created, A class reference created. A is superclass or subclass? Memory allocated to only superclass. See, OB1 dot show. Is it valid? Yes. OB1 dot print. Is it valid? OB1 dot display. Is it valid? No, it is not valid. Okay. See, this is valid. This is valid. This is valid. This is not valid. Clear? So it is valid, it is valid, it is not valid. Now, next one. Now see, next one. BOB2 equal to new B. Here OB2 dot show. Is it valid? OB2 dot print. OB2 dot display. All are valid, no? So here all are valid. It is valid. It is also valid. It is also valid. It is also valid. All are valid. Okay. Now here one more. Third one. AOB3 equal to new B. In this line, which class object created? Which class? Sure. Object is right side or left side? Right side. Object is right side. So B class object created. B is superclass or subclass? Subclass. Then memory allocated to both the superclass and subclass. All memory allocated. Now this object referred by OB3. But OB3 which type? A type or B type? It is A type. It can access only A members. It can access only A members. Okay. Superclass reference can refer subclass object, but it can access only superclass members. Now here OB3 dot show, valid or not valid? OB3 dot print, OB3 dot display, not valid. Okay. But this is okay. But two show methods are there. Two show methods are there. Now it is valid. It is valid. It is not valid. Now here actually this is nothing very simple. This is nothing very simple. In this object, how many show definitions are there? One. That's what it is called. Okay. In this object, how many show definitions are there? Two. First, it is search in subclass. This is only called. Okay. In this object, how many two show methods are there? In this object, two present. Okay. But here, this is only confusion. I'll explain. Actually, here, like this created. Like this created B object, which contains show, here also show, here display, here print. Okay. This object referred by OB3. OB3. Now, in this case, what will be happen? See, in this case, what will happen is this show method also belongs to A. Already I told. It belongs to A only. Okay. This object this part only referred by OB3. Okay, because subclass show method in a subclass defined but belongs to A class only, no? Now in this case, if I call show method, this show method, B class show method called, because overridden. Okay, this show method called. Here, this display we cannot access. Reason, it belongs to B. But this show, how it is accessible? It belongs to A. That's what we can access. Here only confusion concept. This show we can access with A, but this display we cannot access. This is belongs to B. That's what we cannot access. But this is belongs to A. That's what we can access. Got your point? So it is defined in B, but belongs to A only. That is the reason it is valid. Okay. Now fourth one. P OB4. OB4 equal to new A. Now here first of all, B equal to new A. Which class object created? A class. In this A class object, B members are present or not present? That's what it is not valid. First this line only not valid. Remaining I'll leave it. First this line only error. Okay. But here how it is valid? In this B object, A members present. That's what valid. Got it, man? So like this. This first one is nothing, second one nothing, third one not possible now. Later possible, I'll show that is also. Explicit type conversion possible. Then later, polymorphism time will study. Now, polymorphism only you are learning. This is maybe just 1-2 days. After 1-2 days. See, this third one only confusion. See. Now, I'll explain. You observe. Public, static, void, main. String args. Now here you observe. A OB equal to new A. OB dot show. OB dot print. OB dot display. First of all, in this line, which class object created? A class. A is superclass or subclass? Superclass. Memory allocated to superclass members only. Now, in this A object, how many show definitions are there? One. That's what this is only called. Okay. Now, what is the output comes here? A class. This are written A class. A class. Print method. It's an error. It is error. See, file, save. See, Java C B.Java. We are getting error. Where we are getting display place. Display place we are getting error. Suppose I'll remove this. If I write 2 forward slashes, it is comment ignored. If I compile, what is output? A class, B class. A class print method. Okay. So this show method, it calls this one because this memory is not allocated. That is clear. Suppose if I write it is B. It is B. Now, which class object created? B class. B is subclass or superclass? Then memory allocated to both the classes. Both the classes memory allocated. Now, how many show definitions are present? 2. Latest one called B. File, save. B class, print method, display method. See, compilation, execution. B class, print method, display method. These two nothing. Here only confusion. A OB equal to new B. A OB equal to new B. Okay. B object created. Then memory allocated to A members also, B members also. But this can access only A members. Now it belongs to A or B. A, that's what we can access. It belongs to A or B. That's what we cannot access. This one we can access. This one we cannot access. Okay. It is overridden here. That's what always latest only called. Say for example, now what is this? What is 5? Now what I'm writing? What now? What is this? But it is overridden. No? Backside 5 also is there. But what is visible to you? 6. Backside 5 is there. Backside 5 is there. But 6 only visible. So latest one appears. Whatever written last, that is appears to you. But backside that is also is there. This is like a 5. This is like a 5. This is like a 6. You understood? No? So on that overridden. So actually this definition was there. On that it is overridden. That's what overriding method called. Okay. Now OB dot show means this show method called. This OB dot display means it's an error. It is only proof. It is only proof. It is called, it is not called. Because it belongs to A. Otherwise it is also error. No? Otherwise it is also error. See, file, save. When I call error, display place error. But display we are getting error. Show we are not getting error. See, file, save. Compilation, execution. See, this B class also I written in the B class only. No, a B class show only called. B class definition called, but belongs to A class. Okay, but we can call this one. We cannot call this one. Reason, it belongs to A, we can call. It belongs to B, we cannot call. This is only proof. Otherwise, if it belongs to B, can we call? No. We are calling. It is called. That's what it belongs to A. This is only proof. It belongs to A. Got it? So, in this example, A class show method overridden in B class. Okay. Present what I'll do, I'll write B only. All I'll call. After writing this program, the diagram also write. This diagram after program. Write this one first, program write it. Write the program. I'll give a description. Not over. Over. What is the output of this program? Output B class, print method, display method. Output B class, print method, display method. Now this diagram not done. This diagram. So all combinations, write it. Output, write it. Diagram, write it. Everything, write it. So fourth one is error. Okay. First one we should not use, because if you write first one, writing inheritance is waste. First one if you write. So first one we should not use. Then writing B class is wasted. Second and third. Second it is very easy. All will be called. Third confusion is there. That's what I given diagram also. But third also required. Situations I'll show you. Is it over? Is it overall? See. See. Now, actually, this is understanding purpose only. I written print method, display method. Now, it belongs to A. That's what we can access with A reference. This is, it belongs to B. That's what we cannot access. See, if I write A OB equal to new B, if I write OB dot show, if I call, what is output comes? What is output comes? B class. B class. Okay. Now, OB dot display. It's a error. So this one if I call, we are getting error. But this one if I call, working. Reason, it belongs to A class. It belongs to B class. That is the reason. Okay. So it belongs to A. That's what we can access. It belongs to B. We cannot access. Now I'll remove print. I'll remove display. Now I'll remove this. Now give me answer. What will be the output? What will be the output? B class. Okay. File, save. Okay. Now, suppose if I write new A. So here I'll give something dash dash. Now, this statement bound with which method? Can you give answer? Can you give answer? If I pass A class object, bound with this one. If I pass B class object, bound with this one. Got it, man? Now, see, I'm writing new A. New A. Then which method called? This is output A class. Okay. Suppose if I write new B, then B class. So if I give dash something, that is I'll pass later. How to pass dynamically later we'll study. Like objects we can pass dynamically also. So later I'll pass. But binding of this method, is it done with this one or this one? Can you give answer? Can you give answer if I don't give this answer? No. So in that situation, dynamic binding. Which this method call statement bound with this definition or this definition decided after getting object. That's what it is called runtime polymorphism. Okay. Now you write like this only. Write one more example like this. Write it. This statement bound with the method definition after getting an object at runtime. This is known as runtime polymorphism. This statement bound with the method definition after getting an object at runtime. This is known as runtime polymorphism. So objects, if you pass dynamically, then binding done. The binding how to pass object dynamically later. Today not possible. For that library required. So this method call statement bound with this definition or this definition, that is decided after getting object. If new A means bound with this one, new B means bound with this one. Suppose like this, if I pass dynamically, then binding done. That is called runtime polymorphism. Binding of method call statement with method definition is done at runtime. That is called runtime polymorphism, dynamic polymorphism. Okay. Is it over? Just next write it. Not over. Completed all. See. Next note on. In the above example, A class show method overridden in B class. In the above example, A class show method overridden in B class. In the above example, A class show method overridden in B class. It means one show method having two definitions. It means one show method having two definitions. Superclass definition is called overridden method, and subclass definition is called overriding method. Superclass definition is called overridden method, and subclass definition is called overriding method. That is terminology. I'll explain. In the above example, A class show method overridden in B class. It means one show method having two definition. One definition is called overridden method. One more definition is called overriding method. Is it over? See, In the above example, A class show method overridden in B class. Okay. Now see here. It is A class show method overridden in B class. It is A class show method overridden in B class. That is first point. Okay. Second point. It means one show method having two definitions. It means one show method having two definitions. This is one definition. This is one definition. Okay. Next. Superclass definition is called overridden method and subclass definition is called overriding method. So this definition is called overridden method. This definition is called overriding method. See, for example, yesterday I give an example. From relatives family, one person came to Hyderabad, is staying in your home. Okay. The person will prepare one resume. Java course completed. He'll prepare one resume. What he will do? He'll write two addresses. Permanent address, present address. Village address he'll write. Your address also will use for present address. Now, village address is called permanent address. Hyderabad address is called present address. So, one person having two addresses. One person having two addresses. Person one only. Two addresses he'll write. Village address he'll write. Hyderabad address he'll write. Village address, permanent address. Hyderabad address, present address. Actually, his address is that one only, village. But he is using your address. He is using your address. Okay. Here, A class show method overridden in B class. That means one show method, two definitions. But this definition is called overridden method. This definition is called overriding method. Village address is called permanent address. Hyderabad address is called present address. We are calling like that. Here, this definition is called overridden method. This definition is called overriding method. Okay. But why we are calling like that? Little bit confusion. See. Suppose void print. Now, I'll ask question. See, I'll ask question. Is this method overridden? Is this method overridden? No. Is this method overridden? So that's what it is, overridden method. It is overridden method. Now, is it overriding method? Yes. Is it overriding method? No. Like that. That's what this definition called overridden method. This definition called overriding method. Okay. But terminology, what we'll do, little bit confusion will be there. See what I'm saying? This method overridden here. I'm saying. But again, this definition is called overridden method. This definition is called overriding method. So in that program only, you write like this. This definition is called as an overridden method. This definition is called as an overriding method. In that program only write. This definition is called as an overriding method. This definition is called as an overridden method. This definition is called as an overriding method. Is it over? Now, this definition is called as an overridden method. This definition is called as an overriding method. Okay. Now, here, see for example, void print. Here, void display. Now, is this method overridden? Is this method overridden? Yes. Is this method overridden? No. It is overridden method. It is not overridden method. Now, is this method overriding? Is this overriding method? No. It is overriding method. Suppose I will not show A class. Now, it belongs to A class or B class. Can you answer? Can you, if I don't show A class members, can you answer? No. We cannot identify. If I show both the classes, then only can you answer. Otherwise, not possible. Say, this method belongs to A class or B class. Can you answer if I don't show A class? It is not possible. It is not possible. Okay. So, is it overriding method or not? We cannot identify until unless if you see the A class. Until unless if you see the A class, it is not possible to identify. Now, this is actually overriding method. A class method only overridden here. But this is B class member. But when you will understand, if you see the A class, then only you can understand. Suppose, if I don't show B class, can you give answer? Is it overridden? We cannot give answer. That means if you see the both the classes, then only possible. Okay. Is it overridden or not? If you open B class, overridden or not, we can see. Otherwise, how can you give answer it is overridden or not? No. Okay. Is it overridden or not? You have to see the B class. Then only can give answer. Okay. Now, here, is it overriding method or not? We cannot give answer until unless you see the A class. Okay. This is a concept. Overridden, overriding. Like that terminology we are using. That is terminology. Okay. But overriding, overridden, not completed. Now, this overloading, overriding. Next, write it. Overloading versus overriding. Overloading versus overriding. Overloading versus overriding. Yeah, overridden. Overridden means completed. Overriding means still ongoing process. Because binding not done. Binding not done, no, that's what ongoing process. That's what overriding. Overridden, completed. Once if read definition, if written means completed. That's what overridden. But this is overriding method. Binding done later, no? That's what ongoing process. Like that we can say. There is English only, simple English only. Overridden, completed. Overriding, not completed. Like that. Now, overloading versus overriding. Next, write it. One side overloading. One side overridden or overriding. Here, if two or more methods with the same name and with the different parameters list, then it is said to be method overloading. If two or more methods with the same name and with the different parameters list, then it is said to be method overloading. If two or more methods with the same name and with a different parameters list, then it is said to be method overloading. Here, if two or more methods with the same name and with the same parameter list and with the same parameters list, then it is said to be method overriding. If two or more methods with the same name and with a different parameters list, then it is said to be method overloading. If two or more methods with the same name and with the same parameters list, then it is said to be method overriding. Same name, different parameters, overloading. Same name, same parameters, overriding. First, I'll give notes. Let's next with examples, I'll explain again. Second one, in method overloading, return type can be same or different. Same type also valid, different type also valid. In method overloading, return type can be same or different. Same also valid, different also valid. Otherwise, you write like this: can be same and can be different. In method overloading, return type can be same and can be different. Same also valid, different also valid. In method overriding, return type must be same except covariant return type. What is that? I didn't explain. I have to explain. In method overriding, return type must be same except covariant return type. I have to explain, not completed. Next, methods can be overloaded in the same class. Methods cannot be overridden in the same class. Because of ambiguity. Because of ambiguity to call. Methods can be overloaded in the same class. Methods cannot be overridden in the same class because of ambiguity to call. While calling, ambiguity comes. Fourth one, methods can be overloaded in inheritance also. In inheritance also we can overload. Methods can be overridden in inheritance only. Overriding possible only in inheritance. Okay. So only this point I didn't explain till covariant return type. Remaining all over. So overloading possible in inheritance also, overloading possible in same class also. Overriding not possible in same class, but inheritance only possible. Fifth one. In method overloading, access modifiers can be same or can be different. Can be same and can be different. In method overloading, access modifiers can be same and can be different. In method overriding, overriding method can have same access modifier or less restrictive access modifier. In method overriding, overriding method can have same access modifier or less restrictive access modifier. Must not be more restrictive. Now, this is also how to explain. Next, final methods can be overloaded. Final methods can be overridden. No, sorry, cannot be overridden. Because final keyword used to prevent overriding. Final methods cannot be overridden because final keyword used to prevent overriding. Seventh, static methods can be overloaded. Overloading side, no restriction. Overriding side, many restrictions are there. Static methods cannot be overridden because static members, static method does not require object to call. Private methods can be overloaded. Private methods cannot be overridden because private methods cannot be inherited. Private members scope is limited to class only. Private methods cannot be overridden because private methods cannot be inherited. Private members scope is limited to class only. These all I have to explain. Not completed. I'll explain. Main method. Overloading. Possible. We can overload. Overriding not possible because static. Main method is static. Your static methods cannot be overridden. See, main method is static method. Main method we can overload. Main method we cannot override because static methods cannot be overridden. Overloading possible, but that main method only called automatically. Other main method you have to call. Other main method not called. That whatever operating system knows, public static void main string args, that is only called automatically. Remaining main method you have to call if you write also. Now we'll see. Is it over? 8 differences. 8 differences are there. Is it completed, all people? Now, see, method names, first 4 points you observe, first 4 points. These 4 points today, remaining 4 points tomorrow. 4 points already over, just one concept left. Okay. 2 or more methods with the same name and different parameters list. That is overloading. Same name, same parameters, overriding. This is you studied already. Now, if I give whether it is overloading or overriding, can you identify or not? Possible, no? That is. Methods can be overloaded in the same class, but same class we cannot override because of calling. Calling ambiguity comes. Can be overloaded in inheritance only, overriding in inheritance, overriding only in inheritance, overloading inheritance also possible. But actually, this is only how to explain. Covariant return type. Suppose, for example, if I write like this, integer method name get year, float method name get. Now, first of all, it is overloading or overriding. It is overloading or overriding. Over. Okay, well, overloading, overriding only are not identifying. Okay, first definition only not identified. Okay. Now see. Now first you see this is overloading, overriding identification. If 2 or more method, only first one only identification, that is only possible. If 2 or more methods with the same name and with the different parameters list, then it is said to be overloading. Same name, same parameter list is called overriding. Overriding. Okay. Now give me answer. Is it overloading or overriding? Loading or riding? Okay, 1 minute. How many people answer overloading? Just raise your hand. Overloading. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here also 10. Here also 10. Here 17. Now method name get. Method name get. No arguments. No arguments. Same or different? Same means overriding. Method name, same. Parameter list also same. It is called overriding. It is overriding. Okay. But here what I given see in method overriding. It is overriding. It is overriding. Now overriding rules you have to see. Now first, according to first point, it is overriding. Second point, in method overriding, return type must be same except covariant return type. Okay, that is how to explain. Methods cannot be overridden in the same class because of ambiguity to call. Methods can be overridden in inheritance only. So it is not same class. Inheritance is there, so we can override. But problem is here return type int is there. Here return type float is there. It is not same. It is not called covariant also. What is covariant required? Now this is error. This is error. Now suppose class A. Okay, I'll give some other examples. Now first of all, you write this one. Method overriding. Error. Because return type must be same. The covariant return type concept I'll explain with other example. Method name same is there. Parameter list same is there. That is called overriding. Overriding, you can override in inheritance, but problem is return type must be same. Not same. One is integer is there, one is float is there. That's what an error. Error because return type must be same in method overriding. Now int is there, float is there, not same. Error. Suppose here if I write integer, is it valid? Yes. Suppose here if I write float, valid. Okay. Now, for example, another example, class test, class demo, extends test, class sample, extends demo. If I write here return type, suppose here I am writing test. Return type can be class also, no? Already given, or a reference type also. Now it is demo. Now here what is the return type? Test. Here what is the return type? Demo. Now which is superclass, test or demo? Test is a superclass, demo is a subclass. Okay. Now here test is there, here demo is there. Now this demo object, suppose will it contain test members? Yes or no? That is the reason it is valid. This is called covariant. Here test is there. Here test required actually. But demo I written. In the demo also test will be there, no? That is the reason valid. So it is method overriding. It is valid. It is valid. Method overriding. It is valid. Like here, first, what is covariant return type? Covariant return type. Java permits subclass type as a return type while overriding a method. This is known as covariant return type. Java permits subclass type as a return type while overriding a method. This is known as covariant return type. Write this one. So with these three also you have to write. With that only it is valid. Java permits subclass type as a return type while overriding a method. Java permits subclass type as a return type while overriding a method. I'll explain. Java permits subclass type as a return type while overriding a method. This is known as covariant return type. Is it over? See here, return type test. Here return type demo. Is it same? No, it is not same. But previous program, previous code snippet, int float is there. Is it same? No, that's what error I given. But it is also not same, but valid. How it is valid is, here test and demo relation is there. Yes. Which is superclass, which is subclass? Test is superclass, demo is subclass. Here I given relation. Okay. Now here test returning, here demo returning. In this demo, test is present or not present. That is the reason valid. Suppose here if I write sample, valid or not valid? Valid. In the sample also test is there. Okay. Suppose here demo I'll write. Is it valid or not valid? Valid or not valid? Valid. Here test is there. Is it valid? Not valid. Not valid. Whatever is there here, that subclass valid. Same class valid, subclass valid. Superclass not valid. Other class not valid. Okay. So suppose here test is there. Here test is there. Here what are valid? Test also valid. Demo also valid. Sample also valid. Suppose here demo is there. What are valid? Here what are valid? Demo valid. Sample valid. Suppose here sample is there. Here sample is there. Here what is valid? Only sample valid. Okay. Suppose return type A is there here. Here what are valid? A valid, B valid. A valid, B valid. Here B is there. Here only B valid. Suppose here test is there. Here A is there. Is it valid? Is it valid? Not valid. Between test class, A class relation is not there. Here I didn't write extents here. Observe. Is it clear? This is covariant. 4 points completed. Remaining 4 tomorrow. Tomorrow we'll see continuation.